Hello everyone. I just want to make a few short videos related to the topic of quantitative chemistry because some of you asked me question how to calculate the number of mole, how to balance the chemical equations and so forth. On Blackboard, I already make a list of the most important concepts for stoichiometry or quantitative chemistry. So today what I'm going to do is I'm going to explain some of them by giving an example. The first thing that I want to talk about will be the chemical equations. A chemical equation is a representation of a chemical reaction. For instance, the most common chemical equation that you will see will be hydrogen gas reacting with oxygen gas and forming water, and that will be liquid water. So how we balance and how we work with this equation. First, I just want to remind you that always on the left of the chemical equation, you will have the reactants. This is an important, even though it's a very simple definition, but sometimes in some question they will say you product, reactant, and you have to know the difference between the two of them. So on the right, after the arrow, you will have the products. In this case, is the water. And the next thing we need to do beside the aggregation state, which is a gas and water will be liquid at the end, is balancing. How do we balance? Okay, let's just start counting how many atoms do we have for every reactants and product and then making equal. So on the left, we have two hydrogen. How do I know that I have two? Because the subscript two. And on the right also I had two. So hydrogen is just fine. So I would say, okay, hydrogen, I don't need to balance you. Then I will check oxygen. And I noticed that I had two oxygen on the left here because the subscript is two atoms of oxygen. But now on the right, I only have one. So how can I balance? How can I make them equal? Well, if I multiply this by two, then I can have two oxygen. And then I will write a coefficient in front of the water, making two oxygen. One observation or tips: never ever change the subscript. Always add coefficients, but do not try to put the two as a subscript on oxygen because that will be another substance, which is hydrogen peroxide. So going back to where we were before, by adding two here, now I'm affecting the hydrogen because 2 times 2 will make 4 hydrogen, right? And now we had 2 on the left. How can I make them equal again? Well, I had to multiply this by 2. And multiplying this by 2, I had 2 hydrogen times 2 make 4 hydrogen, 2 oxygen, and it's already balanced. Let's try another example of balancing chemical equation. So for instance, nitrogen gas combined with hydrogen gas to form ammonia. That's another important equation in chemistry because this is one of the equations used to produce fertilizers. And then we will start with the nitrogen. That's another hint. Always start with any element different from hydrogen and oxygen. I will show you later an example of that. So we have two nitrogen here and only one nitrogen on the right. How can I make both equal? Well, multiplying this by 2. So I'm going to place a 2 here. And I'm fine now with nitrogen and nitrogen, 2 on both sides. Next, hydrogen. 2 times 3. This 2, which is the coefficient, will also affect the subscript that the hydrogen has. So we had to multiply the coefficient times the subscript, and that will be 6 hydrogen. And then, because checking on the left, I only had 2, how can I make 2 equal 6? Well, multiplying by 3, and then if I multiply by 3, placing a coefficient 3, that will work, right? So we had 2 nitrogen, 6 hydrogen, 3 times 2, 6, 2 times 3, 6. Balance. So that's the way we balance. Let's find another one that I have for you, and that will be, for instance, magnesium nitrate. Magnesium nitrate will be this formula here, a 3 under as a subscript and a 2 here. And it's a solid at room temperature. It can react with ammonia. Oh, well, let me see. Yeah, with water. Let's go back. With water, liquid water, and the product of the reaction will be magnesium hydroxide, which is it will precipitate, but let me write in solution, because some of them will be in a solution and some of them will precipitate. Actually, most of them will precipitate, but let's keep as a AQ. AQ means, for those of you who don't remember, mean equus. I think it's a Latin word, and that will be equal to water. That will be water solution. Okay, let me move. So the magnesium nitrate is a solid, water will be liquid, and the product will be ammonia. That's why I was writing ammonia at the beginning, and that will be a gas. Ammonia will be, let me redo ammonia, and by writing the M properly, okay, because I don't want to get you confused with the, okay, that will be an N. Now let's start balancing again. Oh, I forgot something here, my bad. Magnesium is 2, so we need to write a subscript of 2, and that will be AQ here, right? Now we had, I think I wrote the formula right. This is magnesium nitride. If you want to know the name for each, magnesium nitride, ending ID, water, water. This one is a base, magnesium hydroxide. And the last one will be ammonia. You don't need to write the name, it's just to refresh some nomenclature thing. So let's start balancing, and as I mentioned before, you need to start balancing with any element different from oxygen or hydrogen. So let's start with magnesium. 3 magnesium on the left, only 1 on the right. How do I know it's 1? No subscript, nothing in front. So let's start placing a 3 here, and that will go here. Then I will continue with the nitrogen. I had 2 nitrogen on the left, and if I check this one, I only have 1 nitrogen here. So I had to multiply that by 2 by placing a 2 here, right? Next thing is checking the remaining elements, who are hydrogen and oxygen, and I will do the following. Let's start. I had 2 hydrogen on the left. How do I know that? So screen number 2, 2 hydrogen. And I had 3 times 2. We had to multiply the 3 times the 2 outside the parenthesis, because everything in the parenthesis is affected by the subscript. So we had 6 hydrogen on this magnesium hydroxide, and 2 times 3, 6 hydrogen in on ammonia. In total, we had 12 hydrogen on the right. Let me repeat again. 3 times 2, 6. 2 times 3, 6. In total, we have 12. And only we have 2 here. So if I multiply that one by 6, I can get 6 times 2. That will make my 12 hydrogen on the left. And next thing is oxygen. 6 times 1, 6 oxygen. And on the right, I had 3 times 2, 6 oxygen. That's it. So the equation is balancing. It's already balanced. 3 magnesium, 3 magnesium, 2 nitrogen, 2 nitrogen, 12 hydrogen, 6 here and 6 on the ammonia. and 6 oxygen. 3 times 2 make 6 oxygen. This is an oxygen here. And let's stop at this point because I'm going to make another video how to find the molar mass of the substance, okay?